Engineer Aisha Ahmed is a dynamic clean energy professional, strategic advisor, and sustainability consultant with over a decade of experience in renewable energy, industrial development, and financial and management advisory. As a founder and principal consultant of RE Empower Private Limited, she has done high impact projects across Pakistan and MENA region, delivering turnkey solutions, technical management and financial consulting, and inclusive capacity building services. With a proven track record of successfully collaborating across industrial, commercial, and special economic zone clients, she has delivered her expertise for the project development and investment facilitation and sustainability linked business transformation to the large conglomerates. May I please request Engineer Aisha Ahmed to come to the stage. Now I would like to introduce our honorable session chairperson, Professor Dr. Aslam Ukeli. He is a renowned academic, energy expert, and former Vice Chancellor of Mehran University of Engineering and Technology. During his tenure, during his tenure, he facilitated linkages between Mehran University and national and international institutions and played a pivotal role in elevating universities' ranking among the top institutions. Dr. Bukeli holds a bachelor's in electrical engineering from NAD, a master's in energy from University of Leeds, a master in economics and master in combustion and energy from University of Leeds. His PhD was focused in energy management, policy analysis, and market research in Pakistan energy sector. He has played key role in advancing research and innovation in the energy sector through various leadership roles, and he also served as the chairman of the board of directors of HESCO from 2015 to 2018. I would like to now hand over the session to the session secretary, Engineer Aisha Ahmed. You may please introduce our first author, and then you may call him to the stage.
Respected Chairman, IEEEP Karachi, Mr. Naveen Edgar and staff. We don't have the speech anymore. So, uh, my dear engineer colleagues, ladies and gentlemen, Assalamu alaikum and a very good morning. I'm honored to be the session secretary of the technical session one on energy markets and sustainability. We have a series of insightful presentations lined up today that address critical issues and innovation solutions in the energy sector. Our speakers will delve into topics ranging from the sustainable replacement of outdated infrastructure to the integration of cutting edge technologies like blockchain for a cleaner energy future. We will also discuss the challenges and evolution of renewable energy deployment in the energy sector. So let's begin with our first speaker. Our first presentation is on the accelerated replacement of old PCB contaminated transformers with new and more efficient transformers. I am pleased to introduce Engineer Imtiaz Hiskil, a seasoned power sector consultant. Mr. Hiskil is an accomplished professional with expertise in power transmission, distribution, and energy loss reduction. He has worked on significant energy infrastructure projects across Asia, Central Asia, Africa, and the Middle East with the World Bank and the Islamic Development Bank. Please welcome Mr. Hiskil to the stage. Mr. Hiskil.
We will be presenting online. So we are correct.
So he's presenting online, yeah? topic blockchain applications in Pakistan's power sector, enabling RECs, carbon credits, and voluntary carbon markets. It is my pleasure to introduce Engineer Naeem Ilyas Kanani, CEO of Magna Engineering Private Limited and Volcanica Technologies. Engineer Kanani is a dynamic leader with a strong background in engineering, real estate, and sustainable development. Please welcome Engineer Kanani.
Assalamu alaikum everyone. Hope I'm audible. So, thank you very much. अंदाज़े बयां दर्जे बहुत शौक नहीं अंदाज़े बयां दर्जे बहुत शौक नहीं शायद जो उतर जाए तेरे दिल में मेरी ये बात Respected Chair, Session Secretary, fellow engineers and distinguished guests. It is both an honor and responsibility to present at this prestigious platform the 39th Multi-Topic International Symposium 2025 organized by IEEEP today. This is my second presentation at IEEEP. I made a presentation almost 20 years ago on proposing a roadmap on continuous professional education CPE for engineers. IEEEP has long served as a beacon for innovation and technical progress in Pakistan's power and engineering sectors. And I am proud to be the part of its transformative vision and engineering sectors. And I am dedicating this paper to my mentor, Engineer Roland D'Souza, founder of FND Consulting Engineers, who mentored me and founded my professional foundations. So, skip this. So before going to the introduction of blockchain applications in Pakistan's power sector, first I would like to set the context and deliberate some brief on Pakistan's renewable energy landscape. Pakistan stands at critical energy crossroads, facing climate vulnerabilities while holding immense potential in solar, wind, and hydropower. With COP29 commitments, the SDGs, and our net zero targets, we must rethink traditional systems and embrace transparency, automation, and traceability in energy markets. I would discuss today the role of blockchain in transforming the power sector. Blockchain is not merely buzzword. It is a trustless, immutable, and distributed ledger technology that can radically enhance energy trading, carbon accounting, and policy compliance. I will now touch and present following key terms and concepts which are core of my presentation. I'm an electrical engineer, but MBA by BB. What is MBA BB? MBA is Women Business Administration and BB is by birth. So in every sphere of engineering, and my presentation to my community young entrepreneurs, idea to invoice. कोई भी ऐसा idea जिससे invoice raise ना हो, वो innovation नहीं है. So I am the advisor of Higher Education Commission. I am on boards of almost 13 listed and unlisted companies with Arif Habib Group. And recently I appointed on SOE, state-owned enterprise, Genco 2, and several startups in the US and Canada and Middle East. So now again I'm focusing on renewable energy certificates. The renewable energy certificate is a new concept in Pakistan. Uh, my company, Magna Engineering Private Limited, has started the tokenization of real estate under sandbox testing with SCCP. SCCP is Securities Exchange Commission of Pakistan. And this is the first time that real estate will be tokenized. For example, 1,000 square feet will be fractionalized into say 1,000 tokens of 1 square feet each, and each token will be through smart contract will be registered at National Registry or the custodian. So we are set and going to roll out this tokenization of real estate soon under the supervision of SCCP in partnering with Central Depository Company, NCCPL, Republic Government REIT Management Limited, my company, Magna Engineering Private Limited, Blocanica Technologies, who provided the technology, and a couple of other partners. So renewable energy certificate is a verifiable proof of renewable generation. The carbon credit tokenization turning emissions savings into tradable digital assets, and voluntary carbon markets enabling both local and international buyers to offset emissions transparently. At this point of time, we don't have any such concepts in Pakistan, but in India, they have registered first energy registry for renewables. In Singapore and a couple of other countries, they are practicing the renewable energy certificates. So as I said that Magna Engineering Private Limited is practicing distributed ledger technology, which is a part and parcel of blockchain technology, and going to tokenized real estate in Pakistan. Right now, under the approval, these tokens will be traded through fiat currency, which is Pak rupee. But in future, that can be traded through crypto. The Pakistan Crypto Council has already been established, and I am also working with Ministry of IT and IT and Telecom and other relevant industries to evolve the ecosystem of blockchain and digital assets in Pakistan. Building upon the insights and lessons learned during this process of real estate tokenization, the company name of real estate tokenization, the first company in Pakistan registered is real estate tokenization company with SCCP. The name is DigiState. The DigiState is the first marketplace where any individual or corporate can tokenize their properties. If you want to sell your apartment of 1,000 square feet, 500 square feet, or 100 square yard, or 1,000 square yard, or any land parcel or property, you can tokenize through DigiState. So building upon the insights and lessons learned during this process of DigiState, we are now poised to launch a renewable energy certificate platform in collaboration with the LUMS Energy Institute, NICA, and a couple of other sustainability and energy conservation platforms in Pakistan. We right now initially focused on solar energy production at the enterprise level. Our primary target includes export-oriented organization with installed solar or wind power capacity of at least 1 megawatt. This initiative This initiative will enable automated issuance of renewable energy certificates using smart contracts. So, smart contracts is the name of the mantra through blockchain, and smart contract is a string which is not reproducible and is not immutable. So, the measurement unit for REC would be 1 megawatt hour per REC, and this will help our industries and larger organizations to uh, get green finance from State Bank of Pakistan and other banking institutions. We have already developed a national blockchain REC platform with the name of EcoLedger, and associated with all climate tech and practitioners of sustainability all across Pakistan industry academia. And the EcoLedger would be the Pakistan first integrated platform for blockchain-based REC registry, which will be integrated with voluntary carbon markets in partnership with various certifiers, IoT platforms, and policy agencies. Now I will be coming to my PowerPoint presentation on blockchain applications in Pakistan. So, as I discussed, the introduction is Pakistan transforming Pakistan power sector and blockchain with blockchain. This is the diagram of blockchain. As I mentioned, that distributed ledger technology is the core of blockchain, and we are authorized by SCCP that we have to practice the DLT hyperledger. Uh, Blockchain key advantage: immutable and transparent records, and no hampering of record or is possible in this DLT. And the smart contracts for automation is the name of the game. So as I spoke, key definitions of blockchain, REC, so shipping, carbon credits, and voluntary carbon markets, and smart contracts we recently discussed. NICA will be the partnering organization to this. NICA is National Energy Efficiency and Conservation Authority, responsible for energy conservation efforts in Pakistan. NICA recently made ECBC 2023, and with some world known organizations, and the voluntary adoption of ECBC is in progress, and we are expecting soon it will be compulsion through Ministry of Climate Change for all new buildings first, and then the retrofit buildings. The building management system is very much popular in the large high-rise buildings, mid-rise buildings and industries. So key applications in power sectors are especially in blockchain use cases in Pakistan. So give me a minute. So as we discussed the key applications in power sector, right now we are finalizing the renewable energy certificates, carbon credit tokenization, and voluntary carbon markets. Recently, in COP29 in Baku, Pakistan has evolved the voluntary carbon markets and carbon credit related regulations, and soon the carbon credit market will be the reality in Pakistan. See, voluntary ECPC 2023 implementation will provide the projects of carbon credit, and the ECBC implementation through blockchain will be only possible with the role of NICA, Energy Conservation Building Code, ECBC, and the pilot projects of mixed-use buildings, especially high-rise buildings, and export-oriented complexes, which are mainly exporting textile goods from Pakistan, and tokenizing these energy savings. The technical framework, is integrating tech stack with blockchain, and at a later stage, smart meters and BMS integration for validating RECs, renewable energy certificates, IoT and real-time data feeds, and smart contracts for automatic validation and settlements can be exercised for producing RECs. The global inspirations that Singapore Power Ledger is the reality, and as I said that we have established Eco Ledger in Pakistan. So soon Eco Ledger will be the similar platform as Power Ledger in Singapore. In South Korea, KEPCO Carbon Trading is the VCM, voluntary carbon market in Korea. And in UAE, Smart Dubai initiative. So in our region, UAE is way ahead than other regional countries. So this is Pakistan roadmap. Roadmap for Pakistan blockchain energy transition is that for focusing to start with Lahore, Karachi, and Islamabad to select pilot high-rise buildings and buildings which produce renewable energies more than 1 megawatt, and then regulatory sandboxes. The sandbox is a new mantra for all regulatory organizations throughout the world to test ideas under controlled environment. So Pakistan has already entered into that era, and I'm hoping that IEEEP and other professional organizations to start such sandbox testings, uh, live testings under controlled environment to develop uh, the commercializable and viable and feasible product. So this roadmap for Pakistan. Sorry. I'm just going to finish my presentation within 5 minutes, inshallah. So regulatory sandbox is, as I told, that is the new mantra in this innovative and startup economy. DigiState is also housed at National Incubation Center at University as a startup, and DigiState won uh, 2024 IBA competition. DigiState is also registered with Saudi FinTech recently, and Saudi Arabia and Qatar Financial Center. They want to replicate their sandbox in Saudi Arabia and Qatar. So Pakistan roadmap, platform and ecosystem development which we are doing right now, and stakeholder engagement is a very difficult task with public-private partnership, but we will inshallah will be able to complete this cycle by end of this year. Alignment with the national goals. So private and climate commitments, which Pakistani's Ministry of Climate Change, they already signed government level NDCs, and which will help unlocking the climate finance opportunities, and that will pave the way forward for clean energy transition for Pakistan. These are the strategic advantages for blockchain inclusion in Pakistan. That blockchain is a transparent and trustless system. Uh, Scalable carbon trading is possible through blockchain, positioning Pakistan as a regional energy hub. So business plan for blockchain-based REC platform linked with BCM. The strategic objectives, the link of RECs with voluntary carbon markets, and these are the key stakeholders. Without their support, we cannot implement the whole plan. The key stakeholders and partnerships are government regulators, the IEEEP, Alternative Energy Development Board, NEPRA, SCCP, Ministry of Climate Change, and NICA. All public sector organizations. Standard and verifications, VERA gold standard ISO 14064 and 50001 and CDM. These are the standards. The professional bodies, Pakistan Engineering Council, ICAP, IEEE SDPI, and ICAP for ESG assurance. The technology partners would be Equalaser, as we spoke earlier, Brokenica Technologies for DLT infrastructure, DigiState for digital twin use of RE infrastructure in local data centers. The industry partners would be K Electric, Angro Energy, HUBCO, Aga Steel, uh, because Aga Steel is RE100 corporates and their sustainable footprint, and other P6 listed corporations. And academia and think tanks like NUST, IEEE, Lamps Energy Institute, ComSet, IBA, etc. So core feature of the platform we have already discussed briefly, and this blockchain integration by sector. This is integration of blockchain integration potential by sector. In terms of percentage, the government services, transport, industry, real estate, and power generation companies. So next steps for and call for collaboration. I would suggest this initiative is deeply aligned with NICA's ECDC's 2023 and Pakistan NDC goals and energy efficiency mandate. IEEEP through events like this symposium plays and can play a pivotal role in showcasing such transformative technologies, bridging gap between engineers, regulators, and entrepreneurs, and facilitating national conservation of energy innovations. The call to action of my paper is that we openly invite energy producers to pilot blockchain verified RECs, and especially the August uh, IEEEP Managing Committee and the seasoned professionals sitting here in front of me. Certifiers and regulators to join hands for standardization. We have already started our dialogue with NEPRA. Academic and policy institutions to co-develop framework like Lams Energy Institute and NICA has already been started. I am looking forward to sign an MOU with IEEEP to get support and help from IEEEP. So thank you very much for providing this kind of opportunity, and I will be available for question and answer if session secretary or chairman is allowed.
Yes, sir. The question and answer session will be at the end of the entire day.
Thank you. So nice
Next,
of you.
शायद कि उतर जाए तेरे दिल में मेरी बात दिल से जो बात निकलती है असर रखती है पर नहीं ताकत परवाज मगर रखती है. Thank you very much, sir, for introducing so many mantras, smart contracts, eco-ledger. It was really a very informative presentation. Moving on to the next presentation. Our next presentation is titled The Evolution of RE Planning and Deployment in Industry. We have Engineer Samir Ahmed, Principal Consultant and CEO at Energy Futures. He's consulting to Energy Futures Consulting. To present this topic, Engineer Ahmed has extensive experience in renewable energy, project development, BESS design, and energy efficiency. So let's welcome Engineer Samir Ahmed.
Hello. Assalamu alaikum everyone. Good afternoon. Thank you very much for having me and allowing me the opportunity to share our findings and our learnings in the last for the last 10, 15 years, the work that we've been doing. So my name is Samir Ahmed. Till the time the presentation comes up, my name is Samir Ahmed. I represent a company called as Energy Futures. We're an energy transition consulting firm which helps industries pivot from legacy power infrastructure to more affordable, reliable, and sustainable infrastructure. We have, Alhamdulillah, in the last 5, 6 years, our footprint in terms of solar as consultants have crossed around 3.5 gigawatt. In wind, it has crossed around 100 megawatt. In BESS, which is battery energy storage systems, has crossed 150 megawatt. And as far as energy efficiency, we've covered more than 40 industries on the demand side. And we are also the largest REC supplier in Pakistan, renewable energy certificate supplier in Pakistan in terms of market share. So this is a quick introduction. We operate in Pakistan internationally. So I'm just wondering why. Oh, they're putting the. Perfect. So the idea behind today's presentation is to develop a storyboard of how power sector, the different projects within the CNI has evolved in the last since inception, and how the what are the main drivers. The agenda of studying history when it comes to power is to understand what are the main drivers which have historically moved decisions for industries in what direction. So that's the main outcome that we will collectively try to get out from this session, inshallah. So if we can move forward, we've done extensive research on what are the main drivers and how people change their decisions in terms of where they get their energy from. And it has been, if you can come to the next slide, please, or I can do it. So in terms of the main KPIs, uh, the main KPIs have been, historically speaking, pricing, of course. It has been the availability of supply of power. It has been science-based targets in carbon credits, sustainability, how clean your electricity is. That has now, in the last 10 years, become a very strong KPI. Why people are changing their generation sources. So what I've written over here is SBTI targets. Essentially, by SBTI targets, I mean science-based targets. Essentially, over here you can see. So science. You can come back. Sorry. So geopolitics has also been a main driver in energy, where we get our energy from. Unfortunately, global wars and global trade embargoes have a very significant impact on protectionism as well, have a very significant impact on where we get our energy from. And then, of course, reliability. When you run an industry, you need reliable supply of power. And unfortunately, there are many sources in Pakistan, like the grid especially, where reliability has always been a concern, and why people then tend to explore other options. So reliability is an important prerequisite. And then, of course, policy and how easy it is to manage that asset. These are also important KPIs. So as we move forward in our history in terms of power projects, we see that initially a lot of industries were primarily focused towards the grid. The grid was functioning, it was a small subset. But as soon as industrial growth started to pick up and there was a lot of industrial facilities coming up, and the need for low cost energy became very dominant. There was and there was an abundant supply of natural gas in Pakistan. Um, there were a lot of decision, and because of the pricing KPI, and because of the fact that the power quality was also a concern for a number of industries, a number of industries then pivoted towards putting up their own captive generation, and that captive generation was primarily, the drivers were price and reliability. And we see that a lot of industries, when they were only dependent on the grid, struggled to fulfill their production orders because they didn't have because they didn't have stable power. So the first, pivot from the national grid, which was the first step, was towards captive generation. If we move forward, people started to realize that there are other things that we can further extract from this captive generation, which was the thermal energy from the captive generation that was being done. And again, the main driver for investing in this cogeneration was initiatives was that our overall blended energy cost was further going down because we were using a waste source, which is the thermal energy from gas engines, to run our air conditioning through absorption chillers, and it was also available to generate low grade heat. So that further helped our industries to bring their energy costs further down. Energy can be in any form, right? It can be even in thermal energy. So that was an important step. Moving forward, when once a WHR system started to get integrated, this was the advent when you had solar coming in. It was still $2 per watt, and people started exploring what the potential benefits of solar is. And this is the same time when we had people coming into the system, industries being pushed by by their suppliers to move towards more reliable, so sorry, not reliable, more sustainable forms of energy. So that was a main prerequisite. Uh, the the main drivers were not necessarily during the early days of solar. The main drivers were not necessarily price. It was more focused towards bringing your carbon footprint down. But and so what happened was, as a result of that, a lot of industries started installing small amount of solars, not more than 100 kilowatt. A lot of people have been in the solar energy space know that early days in the solar space, they wanted to try out solar if it even worked or not. So that was very interesting times. Those who went through that process know that everyone wanted to install a small amount of solar and wanted to understand how it worked with their captive generation. Um, People who were with national grids generally didn't have much problems, but people who had were connected with engines wanted to explore it further. So that's how solar started coming into the system. But what happened in the last 4 or 5 years is that the cost of solar went down like crazy, right? We all know that price of solar went down, and as a result, there was another pivot then, and that pivot was the main KPI for that pivot was again pricing, how to bring your energy costs down, and again how to improve your overall carbon footprint. And that's where people started installing solar like crazy, right? Everyone wanted to install as much solar as their rooftops could allow. Everyone wanted to install as much wind as the amount of land that was available. And everyone wanted to install as much as their generators could absorb, essentially. And that's where there arose a number of problems, right? What sort of problems are we talking about? The problems were the generators that were operating with natural gas or HFO. Those started operating at low partial loads, right? Because during daytime you had a lot of solar, and they were operating at 30%, 40%, 50%, because of which your overall efficiency for generation through gas became worse off. And however, in the larger scheme of things, your overall blended cost still went down because you had a large amount of solar. So the problems started to come in generator maintenance. There were other problems, whoever were connected with the national grid or were also connected with generators, there were other problems like power quality issues. For example, solar is being connected in the system. There are a lot of industries that didn't carry out as detailed electrical studies as they should have. And what the result was when large amount of solar came into the system, there was a large imbalance on power factors. There was, new introduction of solid-state electronic device, so hence more harmonics in the system, and hence, there were a range of power quality issues that came in to the system when there was a large amount of renewable in the system. So that was another concern and consideration when there was a large amount of renewables. What happened after that, considering all of the problems that I just told you when you have a large amount of renewable in the system, people started exploring batteries. And now we're talking about like 2021, 2020 in the timeline of where we are right now. Batteries, in terms of cost, also started to come down, but it was still above $200 per kilowatt hour. So even then, it kind of solved a lot of problems for us. So industries were finally able to install more solar. More cheap solar was, possible with the introduction of a battery in a system. So another advantage to those industries which were operating with generators, a big advantage with batteries was stabilization, right? Because during cloud cover events, the ramp up or the ramp down of generators had to be looked into, and at most times, because of frequency issue, there were a lot of shutdowns, there were a lot of blackouts. So the battery allowed a large amount of solar to be injected into the system, and it also solved because a battery is composed of a storage and a BCS, which is essentially an inverter, and an inverter can be controlled to inject wires in the system, right? So it is also a potential solution to a lot of power factor issues, a lot of power quality issues, but not entirely. But it did solve some problems overall for energy systems for our industries. So batteries at that time, and considering the fact that you could finally, with a lot of solar, you could finally turn off an engine, because with large amount of solar, in the last slide, with a large amount of solar, you could not turn off your engines. You had to run them at low load because you had to plan for cloud cover events. So you always need to have that spinning reserve with you, and that is why a lot of industries could not turn off their engines. Finally, with the batteries in the system, you could finally turn off your engines so that without compromising on your overall reliability. So there were a number of value streams, and developing a business case for batteries is a little difficult, right? You need it's not a generation source itself, right? So unlike solar, where you have X kilowatt hours of generation and you have a certain payback, but with batteries, it can even act as a load and a generator both. So you have to develop value streams and quantify them exactly. How much efficiency improvement will happen in my generators? What sort of power quality improvements can I do? For how many hours can I turn off an engine? So that sort of value streams need to be quantified. So that started to happen. And even with the $200 per kilowatt hour pricing with batteries, it still made sense. So people started going towards batteries. And then we had certain areas within, Pakistan which were which had abundant sources of wind as well within the system. So for the first time, and we were the lucky ones to sort of work on a few projects, which for the first time, considering how energy inflation was hitting our industries, for the first time, wind started to be evaluated in captive forms. It was never thought of, right? Wind was always thought of as an IPP, where you have multiple megawatts, 50, 100 megawatts of wind installed. But for the first time, industry started evaluating wind, large scale wind, for captive industry, and that introduced what? It did reduce the blended cost, but it further, worsen the power quality issues because there were a lot of intermittency in the system and a lot of stability issues as well. So reliability became a further bigger problem in the scheme of things. But a lot of wind started to be deployed in captive form where it was possible, right? Because wind, unlike solar, is a very localized sort of subject. Um, Moving forward, okay. So what happened when we had a lot of renewable electricity? We were finally in a scenario, and this is now 2 years down the road, where we were in a scenario where we are curtailing solar and wind, right? We had supplies available, we had electricity more than we needed because we just went out there and installed as much solar and wind that we could possibly with our engines. And then we realized we are curtailing our wind and solar, and in some cases, even inefficiently operating it with our engines. And then it came in and became necessary for us to also evaluate our demand side, right? So a lot of demand comes through, as you might know, a lot of energy demand comes through, generating steam, and a lot of cost is associated to it for a number of industries. And as well as apart from that, HVAC is a very considerable, sort of load area for industries. Cooling and refrigeration is also another area. So, a number of industries then started to evaluate again to be able to use the renewable that was being wasted. They started using all of that energy that was being wasted by installing electric boilers and electric chillers, which was initially, if you remember, once they had gas generators, were using absorption type chillers. So that pivot started to happen. The other advantage of having electric chillers and electric boilers is that it allows you a lot of flexibility in the system, right? It allows you to run that boiler and then turn it off as per your requirement, or maybe not the boiler but the electric chiller you can turn off and turn on with a lot of flexibility. So people started looking at their demand side for the first time. How can we electrify? And that is honestly the future that we believe is that the electrification of heat will be a very important avenue for the future. So, so what is the future? You can see now what is happening in the very recent past is now people with the batteries, the cost of batteries has now come down very significantly. The battery is at the same point where solar was maybe 3 years ago, 3.5 years ago, and the battery cost has gone down very considerably. So what now industries are finally doing is that they're ditching the grid and the captive generation sources altogether. and they're saying that why don't I form my grid through the battery? Why don't I make my own grid essentially? And the cost of batteries is so low. Why don't I just install a larger battery with a lot of storage and serve my load? And that would also solve my power quality issues. That would also solve my intermittency issues, stabilization issues, and that would also solve my renewable utilization issues. So a lot of curtailment happening that all goes around the window if you have large storage. It's essentially like having a large tank, water tank. You don't care when the water comes as long as it comes. You can use that water the whole day. So having large tank gives you that advantage. So now what is happening this year is that industries are now actively using larger batteries. They're evaluating larger batteries for their facilities so that they can entirely take their facilities off the grid. Um, the other things that will be important in the future is asset management, AI-based asset management. So that is where AI will now finally decide based on an economic merit order on how assets will be operated. We're also actively working on another startup in this space, which is an energy data science company, where we're helping powerhouses decide how their assets should be operated. That would be the future again. There is green hydrogen also being evaluated. The feasibility is still a little far-fetched. It's still, under the works. We believe that there's a lot of cost optimization that will happen, inshallah, and people will start to evaluate green hydrogen in their typical gas engines. Hydrogen can also be used in blended form. So there's a lot of innovations happening in that area. And biomass and biogas will also be another important player. Although I'm not a very strong advocate of it, because there's a lot of challenges associated with logistics and surrounding around it. It's not a very local subject as well, but for in order to bring down energy costs, and since it's also considered as sustainable by multiple of you know environmental agencies, it's still considered as sustainable. So a lot of people are opting for biomass, agriculture based, for their steam generation, and which will be an important part in the future. So this is the future outlook in terms of how energy systems will be evolving in the future. So green hydrogen will play a strong part. So Pakistan's microgrid case is a very unique case study for anyone in the world to understand, right? So you don't have that much captive generation in any industry like we have. You don't have wind and solar available like we have. I mean, by saying we have and not other people having it, I mean the amount of resource that is available is significant. So you have considerable amount of wind and solar in the regions where you're planning these projects, and also you have a grid which is not very reliable. So, and in some cases it is reliable, and there are a lot of environmental targets as well. So a microgrid to be designed considering all of these KPIs is super important and is the future of how things will be designed for the future. So this is pretty much it from our side. I mean, internationally speaking, microgrids have been primarily used in Africa, in other places where the grid is not reliable. But in our case study is, a microgrid for an industry, and completely off grid is the future. There are actual case studies where we worked on where the industry was taken completely out of the grid for the whole day, and there was also no gas engines that were run. So there was essentially no base load. So one of the very common misconceptions with the renewables is that you can't run the entire plant on it. That is now going out of the window, right? So we have wind, solar, batteries now running entire industries above 10 megawatt industries. So that will be the future for us, inshallah. So yeah, this is pretty much it. I'm out of time. Otherwise, there were a few technical considerations as well. But thank you very much for the opportunity, and I'm available here for any other questions that you may have. Thank you very much.
Thank you, Samir. I'm sorry for ringing the bell. I actually lost track of time while listening to you. It was really a knowledge concentrated presentation, and it was really insightful that you took us, through the timeline of decarbonization microgrids, BESS, and finally AI-based asset management was really insightful. And for the young energy, students over here, I would personally say that Samir is like an example to be followed in energy sector entrepreneurship, basically. So let's move on to our next presentation. We would now hopefully connect with engineer Imtiaz Hiskil. I've already introduced him, and I'm hoping that it is now working. The connection is working now, and the glitch is resolved. So the presentation, I would, reintroduce. It was the first presentation, now it's the third. It's on accelerated replacement of old PCB contaminated transformers with new and more efficient transformers. I'm pleased to introduce Engineer Imtiaz Iskil, a seasoned power sector consultant. He is an accomplished professional with expertise in power transmission, distribution, and energy loss reduction. He has worked on significant infrastructure projects across Asia, Central Asia, Africa, Middle East, with the World Bank and the Islamic Development Bank. So let's re-welcome Mr. Hiskil.
Assalamu alaikum. Good morning, everybody. This is Imtiaz Iskin.
Walaikum salam, sir. Can hear you well.
Greetings to everybody. Very happy to join the IEEEP Karachi Center Symposium. I've been involved in this symposium since the 1980s and 90s. So I very well recall all the progress that the Karachi Center has made in the past decade. So let me begin the presentation, and before that, I just want to thank the technical committee and the organizing committee uh, for accepting my uh, presentation, which is on a very important topic, a topic which is dormant in this country, not in this country, but in many developing countries. Uh, so PCBs, I mean, I recall hearing about PCBs back in 1980s when I was involved in preparing technical specifications in Karachi Electric Supply Corporation for capacitor banks. And at that time, when I started going through the literature, technical literature, I came across PCB and then I investigated. But that was mid 90s or mid 1980s or something. Uh, Let me give you a background of what has been happening since decades. I mean, PCBs, which is solely chlorinated biphenyl, and they are synthetic chemicals, and they were started in commercial operations, used in the as an insulating materials in transformers and capacitors and other equipment because of their very high insulating capabilities. And since 1930s until 1970s, they were very extensively used. And whenever those equipment was manufactured all around the world, this was a standard insulating material to be used. In 1970s, the research started coming, which showed that PCBs could be a very harmful and with huge adverse impact to human health. The other problem was that PCBs cannot be easily degraded or uh, demolished. And that went on the discussion and the technical experts on this subject until in 1977, the United States apparently was the first country which banned the usage of PCBs in the entire industry. And this was followed by Europe. In many countries in Europe started banning it in mid 1980s.
We will appreciate still
So
more
what are the
silence because
issues?
this online sometimes is not.
What are the issues involved here? First of it, first of all, it persists. The problem is that you can ban the PCBs. Okay, in the new equipment, in the new transformers and capacitors, it will it will not be there. So no problem for the future for the transformer. What being used and the transformer is something. It is not something like it is necessarily to be uh, started stopped using after 5 years or 10 years. There are transformers who are uh, used for 20 years. They are used for 30 years, 40 years. Worldwide, we are seeing even transformers used for 60 years and even more. That's amazing. This is a very this is a kind of equipment which is a useless because there is no moving apart from the passenger. So basically, we believe that the general consensus is that all the transformers manufactured after 95 or 96 can be safely assumed to not have PCB contamination risk. But any transformer which was manufactured before that carry that risk. Next slide. Now the problem with the old transformers, I mean this is not under NTPC or is one of the discos or Karachi Electric. These can be sold to unorganized sector. Once they are in the storage, they can be dumped to kabadiyas, whatever they are, and then they can degrade to the contaminated oil coming out of the body of the transformer capacitor. It spreads into neighboring areas. If it is if there is water around, it can spread further. So there is a huge risk to population. Now, the cost and damages to this inaction is very huge. It is very conveniently said, let's do nothing. And you can see this presentation. It's a video which you can review at your convenient time. We will see how it happened, how they managed the project which was in Poetry Hall to remove the effects of PCB. It was a huge effect. $1 million spent to this, but this was a huge impact on the project because the whole project kind of got into standstill. It could not be afforded. So the thing is, they had environmental and technical specialists who managed this. Now let's come to the elimination of PCBs. So this is the next slide, please. There are a series of challenges to this. First of all, this is not just the area of electrical engineers. Electrically, there are the Ministry of Environment or the Ministry of huge role to play. And when it comes to disposal, the chemical engineers have to play a role, which I will discuss a little later. The biggest problem is the need for reliable data. In a country like Pakistan, this is more prominent. And of course, many other countries have the same problem. Next slide, please. So, disposal and transportation is not very easy. It is very expensive. And sometimes it becomes a huge logistical challenge. For doing anything about PCB's elimination in the society, in the country, in the environment, you need, as a starting point, the screening and testing facility. So you have a huge number of transformers. You have decided that these are older than 1996. So what you do? You have to screen them and test them to find out how much ppm of PCB contamination is there, or if there is no. Basically, uh, this means that utilities have to have a great people who should spend time on this, try to identify this, which comes back to this. We need an organized and sustained effort in this area. Next slide, please. Now, what are the steps to elimination of PCB contaminated equipment? The first is identification. I just mentioned about developing the data. So what is the data? I'm talking, of course, from the perspective of electricity distribution or transmission company. Uh, so we need data for all the transformers. We have decided, okay, all the transformers should be
I think we lost the connection, so we're trying to reconnect. This is an interesting topic going on. We don't generally talk about transformers, PCB contaminated transformers, and to me at least, first thing, there's contamination because of the PCBs. You might continue.
Okay. So I think I mentioned that use a lot of data of the old equipment, old transformers or capacitors, the capacity, their age, how much contaminated PCB oil is there, uh, the transformer's efficiency, and other parameters. And this is not about one transformer, this is about could be hundreds of those transformers. And you don't know how many transformers. This is the worst part. These transformers can be lying somewhere in a uh, remote part of the country. Maybe in the center of the city. Maybe it is in the one of the malls in the city. So the starting point is screening and testing. And in terms of results, if you after the testing you say okay the contamination level is less than 50 ppm, then no problem. You can continue to use this transformer without any worry. If it is slightly higher than 50 ppm, then the transformer contaminated oil has to be treated and then it could be used. But if it is significantly higher than 50 ppm, then this is the biggest problem. That is checked. The contaminated oil has to be drained off, it has to be disposed of through an incinerator, and before that it has been transported where this equipment is available. So very specialized services are available, and it has a lot of work for not only for electrical engineers as long as it is with the utility, but also with the environmental chemical engineers. Next slide, please. Now let's talk about the parameters of old transformer which are assumed to be contaminated and new transformer. The scheme is that we should replace those once we found that these are contaminated transformers with higher level of ppm, we'll replace them. So, so here now we will talk about does it make sense? I mean, no utility has extra money or dollars or rupees to just buy new transformers. They will try to use it. But here is the justification that it can be economically viable. As I worked out, the efficiency of old distribution transformers and old transformers used in transmission substations was much lesser back in 25 years. It has increased significantly, and the reasons are the huge consumer pressure, the environmental pressure, the climate change pressure. So, the utilities are asking for better, more efficient transformers. The other thing is transformer efficiency. For example, even if it was 92%, for example, for distribution transformers back in 1990, it has also gone through the degrading effect. Degrading in 30 years is a significant factor. So once you degrade this further goes down, why shouldn't the efficiency gain for various kind of transformers? When you replace them with a new transformer, could be 5, 6, 7%. It may be more, it may be less. And this is also has to be worked out for done after you have done the particular project and done the right research. So efficiency gain can bring a lot of value to this. The other saving will come from the O&M cost. O&M cost of the old transformers is very large. I mean, I believe this could be as high as 6%, 5, 6, 7% of the capital cost, or can be also termed in terms of the cost of the utilities overall O&M cost. And it costs, of course, a new transformer in terms of operation and maintenance is much lesser, especially for initial 10 years. Uh, and the availability, the other factor is the availability, how much the availability of a transformer for the utility will improve. And old transformers can be out of usage for as much as maybe 20% of the hours available in a year, or maybe even more, maybe less. A new transformer definitely will have very high availability factor. So these are the three factors which basically will determine uh, how much savings you occur. And next slide, please. I think this is a repeat, basically same concept. I don't want to go through this. Basically, what we are saying that you will replace the old transformers with new transformers and just try to work out the same monetary gain. So this is next slide. Cost benefit analysis, which is also called CBA. What you need is system data of the utility, the load factor, the AC tariff, and discount rate, cost of capital. Then you need for both the old transformers and the new transformers their capacities, their quantities, their efficiency, or no load and full load losses, the O&M cost, and availability factors. So you need all these data which can be worked out. So next one, please. So we continue on the cost-effective approach. What we do is in an Excel sheet, we work out the present value of all annual combined net savings from transformers during replacement. So basically, whatever you saving every year, the savings, net savings mean uh, whatever is your reduction in cost or cost, other cost, and minus all the expenses. So you have net savings compared to before, and take a number of years, for example, you can work out for 10 years or 7 years, and then you find a factor of cost benefit appraisal, then you apply the investment cost of that new transformer and other equipment. So this way you can work out how much is the cost benefit factor. Uh, so you have a kind of the project justification for a project, which can be personal by the management of the organization. Uh, so in the experience we have seen that a standalone PCU project is not very easy to be launched. Once the the financing, the issue also is technical and project management of just one project. What is feasible that if, for example, Karachi Electric or one of the discos or NTTC have an ongoing distribution or transmission project which combines this ECC project with that. This will be a component of the project, so it will be much easier. It is much easier to get financing for from any international institutes. Okay, let's talk about next slide. What is the international body is doing for that? I mentioned that 914, the it has become effective. Uh, Secretary of BRS is in Boston, Rotterdam, and Stockholm, which operates with the World Bank, the GF, and then BRF is Global Environmental Specific, which is under the World Bank. And the other agencies which work with them are UNEP, UNGP, and few others. So they have this declared a program, GEP, which is called Global Elimination Program. So concept is that in selected countries will do child projects, which are small projects, which will do exactly what I am saying, that they will find out where the PCBs are transformers and spare the steam and then try to replace them and rehabilitate them or work from. Uh, so they have started one. I think World Bank has started projects in two countries. I think 1990. Countries. And then this concept, this EEP program is based also. The LSP companies will work with the PCBA ignition program, and that way, that is considered a viable way because the other, just leaving the PCB elimination on the hand of a small project without involving the replacement of transformers. And bear in mind, the replacement of transformer is not very easy; it's very expensive. Transformer is probably the most expensive component of the at least transmission and distribution system. So just replacement, if you talk of, okay, we have to replace 500 distribution transformers, this is a lot of money. And when it comes to the transmission sector, it is more expensive. Next slide, please. Another agency is involved in EU, which has launched its own specific regulation. As you know, EU has even for transformers, they are supporting different tier of tier one, tier two of transformers. I think they are spearheading the movement for climate change. So they are very much in favor of replacing transformers with more efficient transformers. EBRD is also EBRD and Development Bank are supporting such projects, and also of course the World Bank I mentioned before. Asian Development Bank is involved more in a broader context of dealing with PCBs. So that's all about this. As I mentioned, I mean, this is PCB elimination may not look a very commercial opportunity for business or for us. For a society, it's very important to take care of human beings, our workers who work in the field, the people are walking around the streets who are much exposed to this kind of leakage from transformer oil. They will just take it for anything. I mean, literally, somebody is seeing a transformer lying somewhere, they can even sort of take some of the oil or some of the material. So it's very risky. So it needs a lot of attention and a lot of capacity building is needed in the country. It is not that everybody has to be trained in this. They have to probably prepare a team of engineers and workers who concentrate on this, and of course financial and technical capability for that. So I think international agency will definitely support. If initiatives come from the country, it will be probably much faster. Otherwise, they see that there's no interest and no pressure from the country. So thank you very much appreciate you for listening to me. And again, thanks very much to the committee and the Karachi Center, and especially for the technical committee. And I must thank Irfan, who sort of encouraged me to speak, present my thing, and also to Zishan. Thank you much. Allah Hafiz.
Thank you so much, sir. We would
If there
like
are any
you to
questions,
stay
we
here with
can
us
take
for
questions.
the question and answer session, please. Um, sir, are you safe here for the question and answer session, please? And I would like to thank you for taking out time and joining us online. It was indeed a very informative presentation. And because we are connected right now and you are online, that's why we are taking your question and answer session right now. With the permission of the chair, I would like to go ahead with the first question, sir. May I? Okay, sir. My question is like we are talking about the replacement of the PCB contaminated transformers, and not a burden, but a cost hitting the uh,
Are we audible?
are we audible? Sir, can you hear us, please? Sir, can you hear us?
Sir, can you hear us? Sir, can you hear us? Sir, can you hear us?
Yes, I can hear.
Can you please shut down that system for
Can you
now
please
because
shut
I'm
down that
connected to the
system for
mobile?
now because I'm so, sir, my question is
That since we are talking about the replacement of PCB contaminated transformers and that is a
contaminated
huge
transformers
value
and
and
that
that
is
is
a
a
huge
huge
value
cost.
and that is
So,
a huge
is
cost.
there any
So,
possibility of
is there
actually
any
converting
possibility of actually
the old
converting
transformers?
the old
Is there
transformers?
any working
Is there
that
any
the
working
old
that
transformers
the
can be
old
utilized and
transformers
can be converted
can be converted
to non-contaminated?
to non-contaminated?
Your voice is coming. Now it's better. Can you repeat if you don't mind, please? Yeah.
So, sir, I think there's some technical glitch with the connectivity. So, we would like to thank you, Mr. On, and we would like to thank you, especially for joining us online, taking out your precious time. So, thank you so much, sir.
Should I wait for the question and answer session?
Many apologies, ladies and gentlemen, for the disturbance. Let's move on with our technical session. Our last speaker is Mr. Kumail Khalili. He will be presenting on the big disconnect, wind power plants and double triggering. Mr. Khalili is the CEO of Zephyr Power and a
See, यहाँ
member
थोड़ा
of the.
मुझे आवाज थोड़ी सी आई थी, but it's okay. If any question they can send me, I can answer. So this is finished, right? Okay. Thank you very much. That's all.
Thank you, sir. Thank you. Mr. Khalili is the CEO of Zephyr Power and a member of the Pakistan Wind Energy Association. He has over 25 years of experience in institutional investment management and the renewable energy sector with a focus on wind, solar, and energy storage. So let's give Mr. Khalili a warm welcome. Mr. Khalili.
That's a very knowledgeable
last year when I did this, I asked everyone to stand up because there was a lot of conversations going on in the back over there again this year. So I request everyone to stand up to stretch for a minute because if there's a conversation that starts whilst I'm talking, it's not polite to the presenters or the people that are attending. Can I get the, sorry, everyone should, it's important to stretch. I've got a PowerPoint presentation, if that's going to be thrown up. आप लड़ सकते हैं पिछले साल आप मुझे माइक के पीछे फंसा दिए या मैं चलता रहता हूँ सर um, the reason I thought this is a graduation of the presentation I gave last year, and last year we talked about the challenges of the technical limits in dispatch. And it was relevant at the time because there's conversations going on what the environment is that the power sector is functioning in. Today the conversation is a building on that conversation because we are in a very different situation this year than we were previously. Because where we ended up now is we've ended up in a case of double jeopardy. And the reason I said double jeopardy is because there's two aspects that one has to look at. There's a technical aspect of what is happening to the integrity of our assets that we are operating and what the long-term ramifications are and what the original thesis was to do renewable energy. And then there's the commercial aspect of what is the impact. What is the impact happening on the sponsors? What is the impact happening on the lenders? And what is the impact happening on the individual consumers? And that is critical to understand because in these conversations that we're seeing, we're having conversations about capacity payments, we're having conversations about non-project risk volume, and there's a lot of misinformation that happens. So I have very few slides. I'll try to be brief because last time I think they tried to cut me off at 20 minutes and I didn't listen to them. So I'll be efficient, and if questions come up, I know we have the question and answer, but I appreciate being interrupted. So my eyesight's a disaster right now. Since in the last year, my eyesight has gone down to the dogs. So very briefly, people say the agreements are not correct. These are very fine agreements that have been drafted by people that are much smarter than us. And these are agreements that are a reflection of 20, 30, 40 years of network experience, of government's experience, of multinational lawyers' experiences. So question ends up being are the agreements at fault, and I'm of the position that the agreements are not at fault because they're well balanced, bankable agreements where you have foreign multinationals investing. The second question ends up being, again, since my eyesight's gone, is that how do you take full advantage of what renewable is? And the only way you take advantage of it is that all counterparts have to follow what the obligation of the agreements are. So in today's thesis, which is not yesterday's thesis, renewable energy is going towards a failed situation. Because ultimately, the way you justify the benefits of renewable is by taking full advantage of the technology. And today, the advantage is not being taken because of national load demand issues, because of grid issues, because of a whole host of issues. And the conversation has to come of not what the generation is able to do, it's what the evacuation is able to do. And better understanding the issues of capacity and of generation. And those separate stories of what we have signed up for as individuals, as people, as consumers. So, yeah, my phone's going off on me. So unless there's a shift in the counterparty behavior, and whoever the counterparty is, the IPPs, the evacuators, the grid, etc., we won't get to the ideal that we're situated in, and it will be, in retrospect, we'll say renewable energy was expensive when the fact of the matter is it is not. So the value proposition that we had for renewables is that you only pay for what you consume, what you generate. Right? That is what a consumer is signing up for. Fossil fuel plants is you're paying for the availability of that generation and the right to avail that availability of generation. So the conversation of, and do people understand that? I just want to get a show of hands. Do you understand capacity on the on the baseload generation and what generation is from the renewable side? Because there's a lot of confusion that exists. So the important thing is to understand that aspect of it. And given that there are no hands, everyone's learned on what the situation is there. But the only way you take advantage is if you understand what the technology is and what the value proposition is for the purchaser and which incentivize the seller to do it. Right? So it's the long-term objective is minimize the levelized cost of electricity generated. Now that's a term that I don't know if people are familiar with. Is that something that people are, do you understand what that term is? Is that a yes or no? It's the present value of the electricity generated divided by the present value of the cost of installing the system and generating the system. When you go in and install the fossil fuel plant, you are locking in the cost of manufacturing, of building the plant, and you are paying for the fuel over the life of the project. For wind, you are not doing that. For solar, you are not doing that. Your capital cost is higher because you're paying in advance for the fuel cost. And if you're paying in advance for the fuel cost, the assumption there is that you are going to take advantage of the fuel that you have for the 20, 25 years. Right? When you build a fossil fuel plant, you're not paying for the fuel upfront, you're paying for the fuel as you consume. So in 10 years' time, when you are running your fossil fuel plant, you will look back and say, what has been the levelized cost of generation? And you don't know what it will be because you don't know what the cost of fuel will be. And over there, you're not paying for the cost of fuel, you're paying for the capacity, the right to avail that capacity from the generator. So the exercise today, where we are today with regards to justifying the levelized cost of electricity is already a failed exercise. Because just for our plant, Zephyr, which is a 50 megawatt project, we have lost, and I'll jump ahead to, I don't think we need to go that. I'll go skip these slides. We have lost in generation 87,000 megawatt hours of electricity in just the last year. Somebody has a phone or calculator. What is the math on that? 87,000, that's megawatt hours, into 1,000 to get to kilowatt hours, into 32 rupees. Divide by on average 270 rupees to the dollar. Let's work in dollars. That's a $10 million loss the plant has had. Multiply that by 38, you're looking at $380 million loss. What has you as the consumer paid? And keep in mind, I've just made a comment in saying renewable energy is only to be paid when you're generating. So you as an individual, as a consumer, have paid me, the wind project, which was designed to run, for the right requirement not to run. And that's the 67, my eyesight's gone again, the 67,000 megawatt hours. So in compensation, you paid me $7 million not to generate. For a fossil fuel plant, that is fine, that's a capacity-driven transaction. You have paid as the consumer for that capacity. For renewables, you haven't paid for that. The EPA isn't designed, that, remember I said earlier, the EPA is designed in a manner that requires you to run. The technical limits require you to run. So what breaks our heart, my heart, as being the CEO of a wind project, and the other 38 wind projects, is our systems are designed to run. So the commercial effect is that it is affecting the bankability of our assets, it's affecting the consumer. Right? Capacity is a separate issue. It's affecting the consumer. It's affecting our electricity rate, but it's not affecting it to the degree you have capacity. Because the capacity is a separate issue, and the only way you get your capacity down is if you increase your consumption. And that consumption is driven by every single person in the room. So that is the commercial aspect of it. Where do our assets go on the technical aspect? What is the wear and tear that we're seeing on the technical aspect? Now I have another deck in there, so if we can go to that. So we've been doing a lot of analysis on our asset for the last 5, 6 years. We brought in a company called Power Factor, which does online monitoring of the asset. And I had a question come to them about 6 months ago, a year ago, 2 years ago. I said, what is the effect of curtailment on our asset? What is the damage that we're not seeing today that we are going to see in 6 months' time, a year's time, 2 years' time, 2 years' time, which is going to have a direct effect, by the way, on your rates, because the insurance is going to go up. If you had one turbine fire, I think it cost the market $5 million. Not necessary, not needed in the process. So if we can pull up the other, excuse me, can we pull up the other deck that I provided? There's a second deck over here. So the question we asked them, I said, what happens when you have curtailment? What's the effect on the asset? And the first effect on the asset, as we're seeing, is the accelerated degradation on the blades, right? Because you're asking a system which is only supposed to act when your generator is hitting maximum capacity, 2 megawatts, which for us is 9.5 meters a second. What happens when you are turning around to a system and saying that instead of being a passive reaction, you have to actively manage a situation to meet a parameter which the system is not designed for? And so we've been, and that's Zephyr, by the way. I'm going to throw a plug in. Everyone's welcome to visit. I have open internships, which nobody takes advantage of. So please reach out to us. So we're in the River Delta. Can we go forward? Um, so here's a good example that I think we can appreciate. The power curve is a beautiful power curve. That's the blue dots. The visual effect of curtailment is what you see in the purple, where you're actively managing the blades which are managing the generation output. So you're no longer trying to maximize the output of the turbine, you're trying to control the output of the turbine in an environment where you're supposed to be, per the requirements of technical limits, be engaged between the cut in cut out speed and follow the power curve. So where does this go? What you'll see over here is an interesting situation where you are looking at the, I think it's the blue line, which is um, um, the curtailment is the red line, and the blue line you're looking at over there is the pitch action. So as a result, for example, when you look at wind, the pitch only is supposed to engage to release energy when you get to the generator limitation, which for us is 2 megawatts. Otherwise, the pitch is not supposed to actively function. It's supposed to be perpendicular to the wind hits it, and then it releases at 9.5 meters. Over here, you have a case where you have active management, and it's happening to a point where if you look at the data which we have, and I'm going to skip to this slide over here. Where is it? Sorry about that. No. There we go. So if you go to this slide over here, and this is giving you an idea of the magnitude of the pitching and the magnitude of the change. When you're in 100% generation, you'll see that it's a number that's somewhere close to zero, which is telling you that when you're normally generating, the requirements for the system to react to the pitching are inconsequential in noise over a period of time. But when you turn around to a system and you tell it that now you have to react in an instantaneous manner, the equipment is not designed for it. You have two aspects. You have pitch motors, which are electrical, GE turbines, etc. You have hydraulics, which are Zephyr. Different technology is being applied, but the wear and tear is still significant. On the GE, you have failure, you have accelerated wear and tear on batteries and the motors. At Zephyr, we've had hydraulic pipes fail because of accelerated degradation.
That's not even looking at, given that you're asking the blades to react in a certain manner, the accelerated degradation on the blades. And the blades are the most important and expensive aspect of a turbine. They're about $1 million, $2 million a blade. And this comes back to the commercial aspect because your insurance is going to go up. So when a system is not designed to be reactionary, the question ends up being, where else is it going? Where else are you seeing the accelerated degradation and damage? And you're seeing the accelerated degradation damage going from the electrical. Oh, this is the slide I wanted. You see it going from the blade standpoint onto the generator one piece. Right? The fire that we had, the GE turbine was a generator issue, from what I understand. When you have a fire in these assets, when the flame goes, the flame goes. There's no saving the asset. It's about saving life. And over here, what you're just seeing is the acceleration of change of the winding when you go into curtailment and when you come out of curtailment. And the question ends up being, is the internal design of the generator designed to handle this? Today we will survive it. Will we survive it for in 5 years, 6 years, 7 years, 10 years, 15 years? And it's a binary effect where if it lights up, if it fails, the turbine is gone. So, whereas we're dealing with these larger issues with regards to grid stability, evacuation, all of these things which we feel for in the sector, what's not being thought about is the larger impact and multiplying it by today's 38 wind projects of assets which you'll find that are no longer bankable because the economics haven't worked, and if the economics haven't worked, then there's no ability for the operators to stably manage the asset and the integrity of the asset, because our job is to protect the asset for the life of the asset. I would like Zephyr to run for 30 years. And ultimately, this accelerated wear and tear is going to damage the integrity over the next 6 years, 7 years, 10 years, and the LCOE is not going to achieve what you want to achieve. In the last 2 years, we've lost 97 megawatt hours of 97,000 megawatt hours of generation. Levelized cost is a disaster. So the exercise we need to go through to save this concept, this theory, is to figure out how to dispatch. And there was a conversation earlier on batteries, and the challenge we have is you build generation assets, fossil fuel, for capacity. Batteries exist for capacity, they don't exist for anything else. So there has to be some fresh thinking as we incorporate in these new renewable technologies onto the distribution network, onto the transmission network, indigenously or external, of how you integrate wind, how you integrate technologies around renewables, rather than renewables being an ancillary selection that we make. If the objective is to go coal, good. Focus on that, design the system. Agree to that. But if the focus is renewables, there has to be a reset in thinking with regards to how you protect this asset, because ultimately these assets are free. You've paid the electricity. We as the consumers have paid in advance for the electricity that we're going to generate. And if we've paid in advance, we're doing ourselves a disservice not running in the process. Those are the two jeopardy points, and I hope people think on these matters, because whilst these are smaller issues, but the grander scheme of things are going to result, because today we are not seeing the cost that's going to incur going forward. Thank you very much.
Thank you very much, Umair to lead that. And it is really a problem. The wind energy sector in Pakistan is, something different from the entire world. Everywhere in the world, they're making use of the free resource of wind, and we, on the other hand, are creating problems because, because of I don't know what. The problems that never actually power generation, right from the gas power generation, those times. And wheeling can be a good solution to this. The industry is moving towards captive wind now, if the resource is available. On the other hand, we are shutting down, and reducing the wind power IPPs. So, there is a big disconnect, as already mentioned. So maybe if the wheeling is allowed at suitable rates, the wind IPPs can, dispatch energy to the nearby industries. So they won't have to, spend their resources on installing captive wind, and their wind IPPs can be saved from shutting down. So,
We should come to
yeah,
that.
sure, we should now. Yeah.
Interesting answer.
Can you please use the mic?
Somebody, please, yeah, take control of mics on one on this side and one on this side, please.
Kumail, can I have your attention? Bilal, we got connected on the WhatsApp. This is regarding the stability of grid for synchronizing the assets. I'm not talking here about the wind turbines, but I'm talking about the gas turbines. We are having a lot of problems not to get synchronized those gas turbines to the national grid or to the gas grid. Any experience what is happening on the NTDC grid? Or what is your experience with the NTDC grid? The stability.
Um, that's a.
Can somebody use the other mic?
I can be loud enough.
Yeah.
That's a. That's a very good. That's a very good question. Um, the cluster of projects that we have in Karo has its own challenges in that we have been operating on a single circuit for the last 5 years, which is feeding 80 kilometers from Karo to Timbuktu. And so, with regards to the grid, I will abstain in giving comment. I think we all know that there are challenges with regards to the delivery of the transmission infrastructure that's needed to successfully evacuate power. But in parallel, the issue is also exists on the consumer side because we have a shrinkage. We have a shrinkage of demand, and that is critical because if you look at where I think the ideal would have been is that all our renewables is able to stay in sync. But unfortunately, there's not enough demand within, yes, Karachi is here, but there has to be a significant increase of demand to manage the issues of non-project missed volume, which is the wind side, and then the capacity side, which is addressing the fossil fuel challenges. But on the gas generator side, I don't step into that space for captive gas generation, but I do believe that there should be a study done on leveraging gas plants to manage the frequency of the grid, and there should be a lot more of an aggressive approach taken for incorporation of battery storage either behind the fence, where if we have a better understanding of the reactive nature of renewables, the reactive nature of the fossil fuel plants and the nature of the renewables, where we can bridge that shortfall, because ultimately the curtailment is a reflection of the inability to manage the ramp up and ramp down of wind versus the ramp down and ramp down of the fossil fuel.
So, my next question is that do we have insulation installed at the NTDC grid? Because you see, I'm right now creating a solution to directly feed the industry from the national grid.
That I can't answer.
That you don't.
Unfortunately, that I can't
Thank you.
answer.
Thank you, sir.
Okay.
I have a question for
Mic
Mr.
on kar
Irfan. Hello, my name is Irfan Ahmed. I have a question for Mr. Thanani. The thing is, we are thankful to Mr. Thanani that he is setting up a registry here. I am representing a big power project, and I'm sitting on 150,000 IRECs, and we can't sell them at the moment because we are in the voluntary program. and they have to be sold to the local buyers. And since our industry has gone down, of the textile and half of it is closed, so we don't have local buyers. And IREC is selling it around zero point 0.1 US cents, I think.
Thank you very much, Irfan.
But there's another issue with this, that 50% of the proceeds have to go to CPPAG, which is doing nothing, just want to have the money. So when you are setting up a registry here inside, have you looked into all these issues?
Thank you, Irfan sir. We
I would
are.
request Mr. Kanani to please come on stage. Yeah.
Thank you, Irfan sir, for highlighting your IREC views. इस वक्त तो ये जो सिस्टम है इवॉल्व हो रहा है और पाकिस्तान में इस वक्त बीसीएम है ही नहीं, वॉलेंटरी कार्बन मार्केट है ही नहीं और नेपरा और एईडीबी और बाकी जितनी भी स्टेक होल्डर्स के बारे में मैंने अपने पेपर में पढ़ा है उन सब के साथ ये इवॉल्व होना है उसमें तकरीबन साल 1.5 साल लग जाता है। जिस तरह मैंने आपसे कहा कि हमने 2023 दिसंबर में पाकिस्तान के पहले रियल एस्टेट की टोकनाइजेशन शुरू की 23 में। आज हमने टोकन मिंट किए हैं इस मंथ में मई में उन सारे स्टेक होल्डर्स को लेके साथ लेके जिसमें एससीसीपी, एनसीसीपीएल, सेंट्रल डिपॉजिटरी कंपनी, पाकिस्तान स्टॉक एक्सचेंज, बिजनेस ग्रुप्स। तो ये इवॉल्विंग फेज में हम हैं, इट विल टेक टाइम और आई विल अप्रिशिएट इफ वी कैन sign MOU so that we can show your intent that you are ready to link with the Eco Ledger and you are offering your credits to Eco Ledger. Any other question? Yes, sir. Sir,
I'll just take it. Kani sir, direct question, engineer Parvez Ali. हमारे पास सेंट्रल कार्बन रजिस्ट्री है या नहीं गवर्नमेंट की जो होती है ना इन ऑर्डर टू सेल आउटसाइड
repeat कीजिएगा सर।
सेंट्रल कार्बन रजिस्ट्री
नहीं नहीं we don't we सर तब तक इसीलिए तो सबसे पहले रजिस्ट्री बनना जरूरी है। We don't have any registry.
3 years ago I remember talking in a place somewhere else तो सोने चलिए सर थैंक यू
नहीं सर वो रजिस्ट्री में जो मसला था ना वो वैलिडेशन बहुत बड़ा चैलेंज था बट ब्लॉकचेन ने हल कर दिया तो वी आर परसुइंग और इंशाल्लाह विद इन दिस फाइनेंशियल ईयर यू विल बी लिसनिंग के ये रजिस्ट्री जो है वो कायम हो गई है नेशनल लेवल पे
फ्रॉड पैन हो जाएगी
जी बिल्कुल नेशनल रजिस्टर भी नहीं है बट इंशाल्लाह जल्दी
Assalamualaikum, ladies and gentlemen. I am finally a student of electric and electronic question object. My question is from sir. Sir, आपने पहले ये कहा कि हम we are going to install the solar on the highest tallest building on the metropolitan city. Sir, we have to connect these solar plants with wires to broadly building solar. तो अगली नहीं लगेगा कि ऊपर से तारें जा रही है और उसको कनेक्ट कर रहे हैं कि लॉसेस भी ज़्यादा होंगे
नहीं we are not connecting anything हम renewable energy credits पे बात कर रहे हैं so we are not connecting any high rise or mid rise buildings or any other organization जो wind renewable energy प्रोड्यूस होती है चाहे वो wind से हो चाहे वो solar से हो इस स्टेज पे कम से कम 1 मेगावाट का इंस्टॉल कैपेसिटी जिसकी होगी उसके रिन्यूएबल एनर्जी सर्टिफिकेट्स जो हैं उसको नेशनल रजिस्ट्री पे रजिस्टर करेंगे और वो फिर बीसीएम वॉलंटरी कार्बन मार्केट के थ्रू ट्रेडेबल होंगे। अच्छा इरफान साहब आपके एक सवाल का जवाब कि हम पाकिस्तान के अंदर पाकिस्तान में जो टेलकोज है ना वो बाय करती हैं जैसे टेलीनॉर है वो बाय करता है क्रेडिट इंटरनेशनली तो हमने हमारा टारगेट है कि टेलीनॉर और बाकी जो टेलकोज हैं जो एमएनसीज हैं स्पेशली इन आईटी सेक्टर स्पेशली इन टेलकोज उनको बाय करना पड़ता है तो हम यही ऑफसेट कर लें पहले फेज में तो बजाय इसके कम जाए देखिए इस वक्त जो मैंग्रोव्स का हमारा प्रोजेक्ट है सिंध का वो आपको पता है कि वो उसकी क्रेडिट गवर्नमेंट ऑफ सिंध जो है उसने एग्रीमेंट किया हुआ वो बेच रहे हैं लेकिन मैंग्रोव्स के अलावा कोई और प्रोजेक्ट नहीं है तो पहले फेज में तो ये नेशनल रजिस्ट्री जब बन जाएगी तो जो हमारे इंटरनल बाइंग है पाकिस्तान से वो इंशाल्लाह ऑफसेट होना शुरू हो जाएगी फिर हम अपने क्रेडिट पे, इंडिया को अगर स्टडी करें तो इंडिया ने ये किया है कि इन क्रेडिट्स को अपने एनर्जी एक्सचेंज बनाया मुंबई स्टॉक एक्सचेंज में, और हर वेडनेसडे को उसकी ट्रेडिंग होती है। तो मेरा एक सेमिनार है, कॉन्फ्रेंस है पाकिस्तान स्टॉक एक्सचेंज में ऑन 8 मई। तो इंशाल्लाह हम भी कोशिश करेंगे कि पीमेक्स पे या पीएसएक्स पे आगे जाके हमारा एनर्जी एक्सचेंज हो, तो मंथली या वीकली ये एक्सचेंजेस इंटरनल सेटल होते हैं।
नहीं, यहाँ जो प्रोजेक्ट्स है ना वो एविडेंट रजिस्ट्री जो यूके बेस्ड है उसमें वहाँ रजिस्टर्ड हैं सारे। लेकिन चूंकि वॉलंटरी प्रोग्राम में है तो उनको यहाँ लोकल बायर चाहिए। आप एमएनसी की बात सही कर रहे हैं, वो बाहर जैसे लीवर ब्रदर्स है चाइना में वो सेल कर रहा है या इस तरह के
लीवर ब्रदर्स भी बाय कर रहा है, लीवर ब्रदर्स भी बाय कर रहा है, टेल्को भी बाय कर रहा है, ये टेलीनर भी बाय कर रहा है।
जी जी, लेकिन यहाँ लोकल बायर्स जो हैं वो नहीं मिल रहे। ठीक है, ये इनको हमें तलाश करना है। और इस वक्त जो
इरफान साहब तो पूरी हमारी टेक्सटाइल इंडस्ट्री है, टेक्सटाइल इंडस्ट्री उनके पास डेफिसिट है।
There's a good discussion, but let's keep it for lunch.
Yeah, okay.
We are running short
Thank
of
you.
time.
Thank you.
Thank you, sir.
Thank you. Thank you, sir.
Thank you,
Thank
sir.
you so much.
Thank you. Thank you.
So this brings us to the end of technical session one. I would like to thank all the speakers for their valuable contributions and the audience for their active participation. Now I would like to call Professor Dr. Mohammad Zamukeli, Session Chair for technical session one, to please say a few words.
Thank you, Ashraf. Thank you, Naveen Saab, for giving me this opportunity to chair this session. Today we have four presentations, and all the four were equally valuable. We have our first presentation uh, from Engineer Naeem Williams, the famous MBA, famous business administration. He talked about very new concepts which are lot of mantras, and I think it's time we should look forward to have this registry for renewable trading, this carbon trading, carbon market, and I think it's a very, very good opportunity for many new opportunities for this new concept. We have, as you all know, that in the last year, Pakistan has stopped probably 22 gigawatt solar plates have been imported in Pakistan, and I think that's huge. And our second presenter was Mr. Engineer Samir Ahmed, and he too talked about how this evolution of renewable energy planning and deployment took place, starting with capture power through gas, and then solar, wind, and battery storage, and then now we are really requiring microgrid controller or the grid, microgrid, and tomorrow there is also a panel discussion on microgrid, because obviously what is happening that the government target, official target about renewable energy, probably we are not meeting, but there is an in-power market. There are so many solar utilization throughout the country, and I think even the government itself is like Kumar Saab has talked about this jeopardy. So there's a jeopardy, and we talk about buying solar from net metering, and especially when, especially from this area of the province of the Sindh, when they are taking advantage, they are already talking about buying solar at a higher rate. So I think that's a dilemma, that our policies do not very much coincide with what we are doing. As Sumer Saab has very rightly pointed out, we have encouraged so much renewable energy projects in the wind sector, but then transferring those power or the competitiveness of those things to the national grid is a bigger issue. In the last 8 years, we are not able to manage that how much we can, and we are talking about curtailment of this power. And obviously, with these things, where a lot of different parties are taking role, and probably Kumen Sahab has not talked about much, but there are a lot of non-state actors also who are playing role in curtailing this power. So the businesses are bigger challenges now, and obviously it looks like this, that the economic growth as this brain drain in the recent past, this the whole economic meltdown, the energy cost. Uh, we as an individual, I'm just giving you my example. Why should I actually
last year I have one battery. Now the battery cost came down, and what is happening in my home that my disco is off for about 10 in the evening, and now I'm injecting another battery so that I can turn it off up to 12. So you see, because the investment in the battery was in a 1 year, you are actually getting your payback quite high. So I think this is very interesting, and the policymaker from the platform IEEEP, which is a very vibrant forum of electrical engineers and electron engineers who are practically bringing these new technologies in it. And now when AI is taking place, where we have now the smart controllers, where we have all our assets can be managed through AI. Even this concept of AI at a very small level, even at our own home, we have these grid controllers. I mean, we can have an EV, electric car, which we can actually charge from the solar. So this is very interesting phenomena. We also have a very interesting discussion on this PCB. I mean, many of us know that the actual use of the PCB was banned in the late 70s. In 79, America banned PCB, but the use of the PCB was allowed in the transformer to a certain level. And this PCB, non-PCB, which is having less than 500 ppm, sorry, less than 50 ppm. So obviously, again, the issue is not commercially, maybe it is not a viable, but then the health issue is a major bottleneck for this PCB, and we should look forward in replacing now those old PCB transformers. And so this is another very good presentation from our engineer Imtiaz through online. Although there was some disconnect, but in the end we heard him, and he talked very good things. So we have very good presentation, and I think everyone talked the new dynamics in this session. But certainly the topic of this technical session was energy market and sustainability. So we have the biggest energy market, especially in this renewable, and I think engineer this Naeem Ilyas Saab has very rightly pointed out this new arena. And thank you very much for all the participation, and thank you for all the questions. I'm sure that many of you have more questions, but during the lunch, these presenters or these authors are around. You can get hold of them and then talk about them. Thank you very much. Already we are delayed. So thank you, Haja, for wonderfully conducting session. Thank you, our IEEE Karachi Chamber President. Thank you all.
Thank you, sir. I would like to hand over the podium to Ishan now.
Thank you so much for all the presenters and session chairs and session secretary. Now I would like to request Professor Dr. Aslam Mughali Sahab to please come forward to the stage, and Ms. Aisha Ahmed will also please join us. I would like to request Chairman IEEEP Karachi Center, Engineer Naveed Ansari, please come to the stage. And I would like to request Vice President IEEEP, Kofi Ahmed Sharif Abdullah, please come to the stage. I would also like to request Honorary Secretary IEEEP Karachi Center, Engineer Imran Zafar Sahab, please come to the stage. Please prepare the mementos. For the first technical presentation, Engineer Imtiaz Iskil Sahab, I would like to request Engineer Irfan Ahmed to please receive the memento on behalf of Engineer Imtiaz Iskil.
It's an honor to receive Mr. Imtiaz Iskil. He was Honorary Secretary of IEEEP Karachi Center before me, about 30 years ago.
Next, I would like to request Engineer Naeem Ilyas Khanani to please come to the stage and receive his moment. was a very interesting presentation, sir. We will look forward to the application of blockchain in the future. Next, I would like to request engineer Samir Ahmed to please receive this memento, and I believe he is not here right now. And Miss Mariam will receive the memento on his behalf. Engineer Samir presented on the emerging technologies in the renewable energy deployment. Next, I would like to request Mr. Kumail Khalili, CEO of Central Power, to please come to the stage and receive his memento. It is always a pleasure for us, sir, to invite you. Now I would like to Now I would like to request Chairman IEEEP Karachi Center Engineer Nabil Akram Ansari and Vice President IEEEP Engineer Tawfiq Ahmad Sharfi Saab to please provide a moment to the Professor Dr. Aslam Ukeli, who is the session chair for this technical session on energy market and sustainability. Thank you, sir, for your presence. I would like to request Chairman IEEEP Karachi Center. Now I would like to request Ms. Aisha to please receive her memento. Thank you so much. Thank you so much, Dr. Aslam Ukeli and Ms. Aisha. Now I would like to call Transpo Power representative or platinum sponsor to please come to the stage and receive their memento if they are available right now. Please. Next, I would like to request representative of Corning Pakistan to please come to the stage and receive their memento. They are the board sponsor of this event. Without their contributions, this event would not be possible. So please give them a big round of applause. Next, I would like to request representative of Jubilee Corporation to please come to the stage and receive their memento. They are the board sponsor of this event. Engineer Adnan Chaudhary. Thank you so much for always supporting IEEE event consistently. Thank you, Mr. Chairman. Thank you, Vice President IEEE, and thank you, Honorary Secretary. Now, the session, technical session one has been concluded, and I would like to request all the guests to please go to the lunch area, and we will have a break for lunch and prayer, and after that we will start with the proceedings of technical session one. Thank you so much for joining us.
Hello.
How are you? Thank you for the question. You're going to get me in trouble. So here's the slide that I was going to share, right? So if you look at please take a look. So if you look at
I don't want to be witnesses.
so if you look at the variation, the delta because your system is not having to do anything until actually a generator is at 2 megawatts, which is at 2 megawatts. At 2 megawatts, for us it's 90 megawatts just because the project is 8 megawatts. At 2 megawatts, the pitch goes down per day because that's the power that we get. So what this is saying is that the pitch goes down per day. When you typically need pitch variation of 7 to 8%, you're actually asking your grid to so your grid is constantly being counted, which is constantly being counted, and it's not designed to be counted to that extent if it happens. So if you look at the leading edge of variance, all an EPCM takes on the leading edge is 6. That's every project. That's every project. And the leading edge of variance translates into effective work
कहते हैं turn around thing हम ये कर सकते हैं. ये चीज़ required process. I'm not very scientific. Presentation वाले ही हमें certificate देंगे. Excuse me, sir, you're talking to the Mr. Boros from my company. They didn't give me the Boros code procedure. I had to write my own code. I had to write. We had to write our own Boros code procedure for hमेशा पिछले fracturing के लिए. आपकी कुछ सुने नहीं. There's a manufacturer in here, right? There's the manufacturer right over there. Yeah, here, right? Not recommended here. पाकिस्तान में कितने प्रोजेक्ट लगे हैं 38. हमारे से पहले तकरीबन 20 लगे थे. कितने प्रोजेक्ट के अंदर सुना करे हैं? Why is that? Because material law degrades. It faster, much faster. It degrades faster, and your location system. If you look at the capacity factor of Septima, T19 capacity factor is 37%. If that slide, if you could make sense of that, that slide was visible to you guys because of that stupid screen. The problem ends up being the lost energy that I have. So if you say, okay, if my system was supposed to generate 27% capacity factor, chal jata. My system designed for 37%. In the last 5 years, I've generated 44% one year, 41% the other year. I'm designed to run. CPPA machine. No, CPPA doesn't. It's transferred to the SO. The problem is the system on no, they don't curtail. They tell me to curtail. It's either done through NPCC or RCC. NPCC link the power not under the agreement. Not under the agreement. But here's the thing. Why is my electricity being sent to Jampi 80 kilometers away? I've got Dhabechi here, 10 kilometers away. Dhabechi substation. Only in Dhabechi. Yeah, but I'm nowhere close. I'm 80 kilometers from there. No legal comment on that. But we have 800 acres of mangroves that we do conservation on. I've gone swimming on the wind farm. I've gone swimming on my wind farm. I've got fantastic fishing. The amount of environmental, it's not about this project. I might as well. So here's another thing you want to know. We've got zero joints in our collection system. Southern India, longest cable is 53 kilometers. Zero joints through wetlands. Zero joints. The cables come on what length on a road? केबल का लंबाई क्या होता है रोड में? 1 किलोमीटर. So we had to, the EPC contractor made a mistake. Insurance had to pay $500,000 for the new cable. We developed procedures to install our cables through wetlands, which were verified by 7 different professional organizations. No one ever installed submarine cables less than the site. And fiber optic cables are also subbraided. Submarine is shielded, bitumen, shielded. Yeah. बहुत मजेदार था. Watch it. काश मेरा नंबर है. आज मुझे नहीं मेरा नंबर आपके पास है. मुझे आपसे मिला था टेक्निकल एस्पेक्ट आपकी जी हाँ बेसिकली जी हाँ you were saying curtailment जबकि curtailment मेरे फोन पे ना गैस टरबाइन. So there's two aspects, right? There's degradation of the power converter that you're creating. There's degradation of the equipment of the production. So physical degradation. The physical degradation is when so fiber optic cables are insulation. Right? I turned around to the tower ownership and I said, you should pay me. Because I've had to pay them cable insurance. Because my insurance hasn't gone up. My
and then we can discuss
I'm
making
going to
sure.
grab lunch,
Sure.
but don't worry. You and I can talk because I'll be only half an hour.
It's very unfortunate I got this somewhere else and we could not
But
meet up.
he has my number. You have my number. And whoever wants to learn Chicago, don't miss it.
I was a small follower. I used to go in Allahabad,
So
but
you've seen the falls. You've seen them.
but no, not before. Till that, I think
No,
when he
you've
was
seen
there,
them.
yeah.
So you've gone on the national highway.
Yeah.
Right? The first song you sing on the national highway is Boom Boom. Absolutely blew my head. That's the one.
Yeah, because I'm getting towards the
After Bhaveshri is
It's
close to
after Bhaveshri before
close to,
Karwar.
but it's on the main national highway.
No, you take a right on Franklin and
Also,
over there you have
वो तो
7
काफी
it's like
काफी
Coastal
काफी आगे है
Coastal Highway.
पहले कोस्टल हाईवे वाला I know
You
बम्बोर वाली
have,
होगी वो
here's the thing, you have 7 new stations there. Seven.
yes.
All of a different civilization. You've got the 42 acres where the Maulevi Falls is. You've got the Coastal one. You've got the project where the Hafsa was shot. You've got the Future House. You've got the Mango 35 acres. You've got the leather. No, you've got Kanaga, which is the cheese outside. Then you have another facet of the city, which is Ghazipur, which is inside of the Carpathian border, completely near the Pakistan, and it's a beautiful border. It's a beautiful city. So you have the roads on both. You have all the assets.
Yes, I heard about that.
You
वो
don't
तो मेरे
miss.
को क्या अच्छा आपका जो है when you were complete उसका manufacturing किसी में नहीं हुआ already
LM doesn't manufacture. It's still LM.
okay then
LM is now owned by GE and they don't own it. Yes. And you have a fairly significant manufacturing base. And this one is GE.
उसका लिखा